Robot Friction Workshop. What is the relationship between frictional force, velocity, and different surfaces? In this experiment, we will measure frictional force by taking a robot at 4 different power settings over 3 different surfaces and examining our results. In order to get this done, we are going to start with the hookup of the Newton scale to the robot. So the first thing we want to do is we want to calibrate our scale. That's important. Just hang it, make sure that it's at 0. If it's not, adjust the nut to make sure it's at 0. Second thing we do is we've designed a hook at the back, sort of like a trailer hitch at the back of the robot. This is going to be the way that we're going to pull the scale. So now when we hook up the Newton scale to the robot, we start by taking the trailer hitch, for lack of a better word, off of the robot, and we'll take off the small gray part at the top and attach the loop of the Newton scale to it. There's 2 parts to a Newton scale. There's the loop and the hook. We want to make sure that we're attaching the loop part to the robot. Also, we want to make sure that the proper part of the scale is facing up. Make sure your wires are out of the way because they can interfere with the reading. The part of the scale that's facing up is the part that says N. So there's 2 sides to it. Just make sure the part that says N is facing up. Next, we're going to go to our programming setup. This is basically getting the robot to pull the block with 4 different power settings. So we're going to make 4 different files. And this is how it's going to look. I put in a sound block just to make sure that we know that we're starting the right program. We put in a little timer, a 2-second timer that gives you a little bit of time once you press the start button to get things measured. And at the very end, we put another sound block to let you know you're done. You can make any sounds you choose. But really the heart of the program is a very simple movement block. And we're going to set that movement block to go 12 rotations. But the real difference is going to be in the power. So the first time we're going to set it up, it's going to be with 25% power for 12 rotations. We're going to save that, and then we're going to set up an identical program with power settings at 50%, 75%, 100%. We're going to call them PYS_25. So what you saw happen right there, we're just going to do 3 more times. We're going to wind up downloaded onto the robot the programs. We're going to place the block in place, and here's the robot going at 25% power. As you can see, it's very slow. Observe the Newton scale and what the reading is on the Newton scale. We take that reading and we mark it down on our clipboard. Also, remember to mark what surface you're on. So that's the smooth sandpaper at 25. Next, we load up the program that has 50% power. You'll notice it going a lot faster. Again, we're going to observe what the Newton scale gives us in a reading. We take that reading, we mark it on our clipboard. Next, we find the program that offers 75% power. Notice it's much faster. Observe what the Newton scale reading is on that. And we mark that reading on our clipboard. And finally, at 100% power, we are going to mark what the Newton scale reads as frictional force between that block and the robot. We're going to take that reading and we are going to put it on the sheet. And once we get all of our data, we're going to open up Microsoft Excel and we're going to enter our data into columns. So on the A column, we enter the 4 power speeds, and then on B, C, and D at the top, we enter the 3 different surfaces, and then under respectively, we make our table. We go to Insert, select the table, Insert, and go to Chart, and here we can find the data showing us what's really happening with the frictional forces. And here we are in action.
Who's taking the reading? Take a reading.
Wait, is it on the maker side? It's not on the maker side.
No, it is. It is. You're on the right side.
Wow. 300.
Are you marking it down on a piece of paper? Mark it down. Mark it down. That's 25. Yeah. Oh yeah, that's the other thing. You gotta make sure it's all clear. Make your best number as accurate as you possibly can.